All right, so what we're talking about today is slopes of parallel and perpendicular lines. First of all, we have to make sure that we know some things about slope. The first thing we need to know for slope is that it's the rise over run. And this matters when we are counting. So when I'm given a graph and we count. And so remember, I go up or down first. And then from there, I go left and right. So what's confusing about this is it's the opposite of what you do when you graph coordinates. The next thing you need to know about slope is the slope formula. And you've done formulas before, so this one I think will be okay. When we get to some examples, you'll see. Now, one thing that happens when we're dealing with slope is some people get confused on when it's positive and negative, and there's a good way to remember that, and that's called slope guy. So sometimes you have lines that go up, and those are pretty positive, but sometimes lines go down, and they're negative. You could also have horizontal lines, and with horizontal lines, the 0 is on the top of the fraction, and then you can have vertical lines, and that's when they're undefined. So that's slope guy. And so the things to remember is if I have a 0 on the bottom, that is undefined because you're not able to walk up a vertical line. And then if I have 0 on the top, that is a no slope or 0 slope, and that is going to be horizontal. Okay, so there's a lot of different things to remember for slope. You have to remember, first of all, that it's up and down, then left and right. It's rise over run, you got the slope formula, and then you have to remember directions. So what we're going to do is I'd like you to graph some points. Let's graph -1, 4. We'll call that A. 3, 3. We'll call that B. And then we'll call this one C. And then 1, 1, D. Okay? All right, and so what we're going to do is we're going to find the slope of some lines. And so I'd like us to find the slope of AB right here. And then we're going to find the slope of BC. Actually, let's not do BC. Let's do DC right here. Okay? So for AB, the key that I like to do is I always like to start on the left-hand point. I like to start here on the left, so that way I don't have to worry about double negatives. So to get from A to B, I go down 1, so it's -1, and then I go to the right, 1, 2, 3, 4. So I go to the right 4. So my slope for AB is -1 over 4. All right, I'm going to change colors real quick to do DC. To go from D to C, again, I always start on the point on the left. It doesn't matter if it says DC. Remember that CD is the same as DC. So I'm still going to start at the C because it's on the left. And I have to go up 1, 2. So I rise 2 over, and I go over 1, 2, 3, 4, 5. Now, if I were to connect these points, you can see that that is like the eye that goes up, so that's positive. And then this one here goes down, and so that's negative. So we got a negative slope for AB and a positive slope for DC, which is correct. The next thing that I want you to learn is there's a saying or a little song that sometimes I sing because it helps people remember it. It's not really a song, but it's just something that helps people remember the rule about parallel and perpendicular slopes. And so what it is it is parallel slopes stay the same, perpendicular flip and change. So Parallel slopes stay the same. Perpendicular, flip, and change. You say that about 5 times and you're going to have it memorized. So for this one here, my original slope was negative 1/4. So I need to find my parallel and my perpendicular. Well, parallel slopes stay the same. So this is negative 1/4. Perpendicular, flip. So it becomes 4/1. And since it was negative, it becomes positive. And so that is just 4. And then here, that's my original slope. Parallel and perpendicular. Parallel slopes stay the same. So it'll stay 2/5. Perpendicular, I flip it and I change it. Now, since it was positive, that means it becomes negative. And so that's how you find slopes, parallel and perpendicular, when you know one of the slopes. All right, now let's look at some slope problems. First of all, I'm going to go ahead and grab this formula. Okay. And we're going to kind of insert some space and have it down here, because now what we're going to do is we are going to do problems without the graph when you just have coordinates and we need to find what's going on. Okay. See if I can get that to paste somewhere good. There we go. That fits good. Okay. So now whenever I'm doing a problem like this, the first thing I want to do is I want to label my x1, y1, x2, y2. Now I'm going to plug it into my formula. So my y2 is negative 5 minus my y1 is 3. X2 is 4 minus x1 is negative 2. So I get negative 8/6. And so that reduces to negative 4/3. Now it does want parallel and perpendicular. So my parallel slopes stay the same. Perpendicular, I'm going to flip it and I'm going to change it to positive. Give us some space, okay? So for the second one and the third one, I'd like you to try the same thing. I'd like you to find the slope and then see if you can find the parallel slope and the perpendicular slope for both of them. But again, first thing you do is you're going to label your points and then you're going to plug it into your equation. So when you think you have it, press play so that you can try it out and see how you did compared to mine. All right, so you should have labeled x1, y1, x2, y2. So I get y minus negative 3/4 minus 4. These two negatives become positive, so I get 4/0. Well, you're not allowed to divide by 0. This is right here. When I divide by 0, it's undefined. And so that's my answer. It is undefined. Well, parallel slopes stay the same, so that means this one's also undefined. Perpendicular, flip, and change. Well, undefined is a vertical line, and the line perpendicular to that is horizontal, so my perpendicular slope is 0. All right, so let's try the next one. x1, y1, x2, y2. And so 6 minus 2/1 minus negative 7 gives me 4/8. And so that reduces to 1/2. So parallel slopes stay the same. Perpendicular, I flip it and I change it. So it just becomes negative 2. All right, the last type of problem, we need to write this equation because we didn't write it up above. We kind of ran out of space. The last one that we're going to work on is we're going to work on something called point slope form. It's kind of a funky looking formula or form, but after you do a couple of them, you'll get used to it. And so it's y minus y1 equals mx minus x1. There's 3 things that you plug in. You're going to plug in your y1, your m, and your x1. The other things do not get plugged in. They're just there, and you use what you have. All right, so my 2, negative 2, that's x1, and my 5 is y1. So I'm looking at my equation, and it says y minus y1, so 5. Oops. Okay, let's get my mouse back. So it's y minus 5 equals my m, 1/2, x minus x1, which is negative 2. Well, these are going to become positive, and I'm going to distribute. So I get y minus 5 is equal to 1/2 x plus 1, because half of 2 is 1. So now I add 5 to both sides. I have to put it with a number because it can't go with x. And so I get 1/2 x plus 6. Okay, over here, same thing, x1, y1. I'm going to plug it in. So it's going to be y minus y1. So that's, keep making that mistake. Negative 8 equals my m, 2/3, x minus my x1. So right here, this becomes a plus. 2/3 times x is 2/3 x. When I do this, I get 6 over 3, because 2 times 3 is 6 over 3. But 6 divided by 3 is just 2, so I can write minus 2. Now to finish this off, I have to minus 8 on both sides. And so I get 2/3 x minus 10. All right, now sometimes problems like 6 and 7, it says the word parallel and perpendicular. Well, remember, parallel slopes stay the same. So my parallel slope is going to be 3/4. So now I do the same thing, but when I use slope, I have to use this new slope here, which it actually isn't new, it's the same thing, but I still have to use it. And so it's going to be y minus y1 equals my m, 3/4 times x minus x1, which is negative 4. These become positive, so I get y minus 9 is equal to 3/4 x. Now when you distribute this, 3 times 4 is 12, and then it's just divided by 4. Well, 12 divided by 4 is 3, so it becomes plus 3, because those two negatives make it plus 3. So to get rid of a minus 9, I add 9 on both sides. And so I get y is equal to 3/4 x plus 12. And that's the answer to that one. For number 7, that keyword is that it's perpendicular. So now I need to write my perpendicular slope. Well, parallel slopes stay the same, perpendicular, I'm going to flip it. Well, 3 is 3 over 1, so now when I flip it, it becomes 1 over 3. And when I change it, it's going to become positive. So now I'm going to list my x1, y1. And so y minus 4 is equal to x. I'm sorry, not x, but m, 1/3 times x minus x1, which is 3. So I get y minus 4 equals 1/3 x. Okay, let's multiply our fraction again. 1 times 3 is 3, divided by my bottom 3. So I just get 1. And to get rid of a minus 4, I add 4. And so I get y is equal to 1/3 x plus 3. So there's a lot of different things to remember about slope. Remember, if you look at the graph, it's rise over run. If you have coordinates, you have to use your slope formula. And then you also have to remember our saying, parallel slopes stay the same, perpendicular, flip, and change. And then you also have to remember how to use this point slope form.